Cool. 1105, filling bookcase shelves. Um, we have a sequence of books. The I book has thickness book sub I sub 0 and height book sub I sub 1. We want to place these books in we want to place these books in order on the bookcase shelf that has a total width shelf width. We chose some of the books to place on this shelf. I don't know why I'm reading this way, but it's like a tongue twister. We chose some of the books to place on the shelf such that the sum of their thickness is less than or equal to shelf underscore width. Then build another level of shelf on the bookcase so that the total height of the bookcase has increased by the maximum height of the books we just put down. We repeat this process until there are no more books to place. Note again that at each step of the above process, the order of the books we place is the same order as the given sequence of books. Okay, that's fine. Return the minimum possible height that the total bookshelf can be after placing shelves in this manner. Excuse me, man, I'm having burps. I'm just drinking water. Okay. So now we have an example. We have 1, 1, 2, 3, and a bunch of stuff. I guess this is the 2 sub 2. Shelf width is equal to 4. Okay. And n in this case is number of books, and n is 1,000. Notice that book number 2 does not have to be on the first shelf. Of course. Okay. Total bookshelf. Okay. So I'm having a couple of thoughts just to kind of think through how I want to think about this. So my first inclination is very often, especially if you look at n, and n is 1,000, say, which means you can generally do like n square stuff, maybe n square log n if you're really fast about it, or you're not doing anything super crazy. Yeah, so then my first case is that it's dynamic programming is some sort of memorization type thing. I'm also my second thought, I guess, is just to see if is there some sort of greedy-ish algorithm that we could use? I mean, not too greedy. Like you can't just literally like fit books as they go. Otherwise, this would be a really dumb question, or at least not dumb, just I don't know. I guess there are a couple of problems that are like that though, where they just tell you stuff and then you just implement it. But it seems like even this like example kind of proves that well. But there is maybe you could do like a little bit trickier, but but I think yeah, I'm still gonna lean toward dynamic programming. I'm just trying to think about what it means, right? So I think one of the dimensions that I would think about is kind of is the number of books, like given or not the number of books, but the nth book or the ith book. Or what is the other dimension? I think to look at constraints a little bit more, there's the height and the width is less than 1,000. Wondering if I can exploit that. Because, well, I mean, if I can. Oh man, I got a message with. Yeah, I mean, I think this is just like it's a really wordy problem. It's just that I mean, you're just trying to minimize the number of total height of shelves, but not the number of shelves. So it's kind of like where do you put the divider type thing, and the costs of these functions are just the sum of the things, and in that way, maybe it's a dynamic programming. It's a shortest path problem, actually, which can that would be interesting to look at, because in this case you just have an edge from 1 to say 3, and the cost of that is kind of depending on Yeah, the shelf width, and then you kind of, yeah, I mean, so the cost. Hmm, can you do greedy with a shelf? Hmm. But yeah, so I'm just still kind of thinking around whether I could just do it with dynamic programming, where uh, the dimensions are the iBook and 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 kind of something about the height maybe. Yeah, you can't sort by the thickness because I think they literally has a sentence that tells you that the order of the books have to be in the given order. Um, but I think I think this is a good example of just the 1, 2, 3 because mm, so the best way to put shelf 7. Yeah, I mean I think that's fine. I think the state that I want to put for my dynamic programming is the iBook being the last book on this shelf. Uh, and is that enough? And then the rest is greedy-ish. Hmm. Yeah, that's. I think you could probably do it dynamic programming, but now I'm thinking about it in terms of uh, DP. Uh, the last where the YU is the total, where the YU is the shortest path from node 0, which is the sum of the heights in this case. Um, yeah. Let me just crank out some template just to kind of help me visualize this. Because let's say you have the first three element here. I'm half explained to you and half explained to myself, to be honest. But if you look at this, I'm pointing, but you can't really see. Um, you could look at, let's just skip 4, 5, 6, and 7, and we just have 1, 2, 3. There are two paths to it, which is one, well, there are a couple of paths, which is, yeah, 3 connecting to 2 or 3 connecting to 1, and they both have associated costs. Uh, eh, but the cost function is probably the yeah. There's probably a second dimension that I'm not considering to kind of consider to make the cost function a little easier. But oh, I guess width left. Yeah, okay. And I guess the other dimension is shelf width left on this rack. Yeah. So then you would have something like, do I want to do it in C? No, do it in C so I could, excuse me. Okay. Let me just go in memo. Uh, let's just take the max. I guess the max is like 1,000,000 or something like that. So just okay. Now the answer is just calculate for calculate forward or backward. I guess it doesn't really matter if we calculate forward or backward. So I have to cache some of this stuff. These are stuff that you can actually pass into the thing, but I just want to shortcut it so I don't have to keep typing a lot. But if you want to do it cleanly, you probably should do it that way. Maybe just go max. That's fine. With left. Okay, so what does it mean? How do I calculate the books? Right. So, well, so the shortest height. Oh, this. Maybe I need another dimension, but I don't know how to represent that, which is the max. You can't do n cube, right? So that's not cool. Oops. Well, you could do greedy to some degree, so maybe this shouldn't be width, this should be height. Yeah, okay, this should not be width because this is a medium, but possibly a slightly more difficult medium with some definition of slightly. Also, welcome joining us, Alex. Yeah, this should be 5. No. Maybe I don't need this actually. I mean, it's fine. Just glad you're here with us in general. Maybe okay, I'll leave this here for now. I don't think I need it, but because I think what I want to do is, yeah, I mean, I'm dying right now. I mean, not really, I'm just kidding. But it is tougher than I expected. I was like, oh, yeah, let me just do a quick one. But yeah, I think that's what, yeah, sorry I'm out. Thanks for that drinking monkey. I think I'm articulating it poorly because I'm just like doing a lot of things in my head. But I think I'm, what am I doing? So total equals 0. So I think I'm doing the cost function now, doing like the last X things that'll fit. I mean, you'll see in code, maybe I'm terrible at explaining it, but I think there's some concepts in my head that I'm, that I have to put together. And sorry about that. I is equal to index. Yeah, I'm like, I'm good at saying what I'm typing, which is like those comments where like, oh, when you ever see comments feel like, oh, I recommend here, I here. No, I'm just kidding. Okay. So total plus, oh, I forgot to bring the array over. Okay. Yeah. I'll dock myself points later. But okay, so that's the, just to make this a little bit more readable about what I'm thinking, given that I'm not going to say at least make the code readable. This should be the width. So which one is the width again? Oh, the first index, okay. Width is less than width. Maybe I should have just called this shelf width. Well, it's too late. It's not too late, I'm just lazy. But then, okay, say best is equal to infinity. S is equal to, I reset that to infinity. And let's get another value. Value is equal to calculate I minus 1. Yeah, I mean, I think that's it. Plus the cost function, which is the maximum height of the number of books you scanned, which I didn't put in. So, okay, max height. I'll get into that at the end. I think I actually have something that I go through mentally a little bit, so I would definitely get through the greedy versus DP. But give me a second. I'm on this train of thought. So if the height of this book is bigger than max height, and max height is equal to the height of this book, and the cost is just the max height of the stack of books scanned. And then now if the cost is less than best, then best equal to V, and then now nope, yep, because I didn't need this after. Yeah. I'm just going to run just to see if it compiles, because I probably have a typo somewhere. So this is not a. Oh yeah, wait, what? Oh, I did not put in the base case, but at least it compiles, I guess. It's kind of not really. Okay. Index is 0, return 0. That's maybe the only base case. Okay. I mean, it's right for the example case. We can't put something funky. I guess I'll just put in random stuff and hope that the whatchamacallit will take care of it. What happens if, well, I guess this gets enforced, so wait, maybe I just have a typo somewhere on the actual example or something. Well, the expectation is wrong, but my code is right. but actually, I don't know. Oh, I forgot a comma. I guess my code isn't necessary. Right? Let's submit it and fingers crossed. Okay, wow. I mean, okay. Yeah, I think I think I kind of thought this, for some reason I got confused a little bit. I think so. So let me kind of step back a little bit and kind of walk through my thought process. And I probably made this problem a little harder than maybe it should be, but I don't know. But there is a, because I think I got a little sidetracked a little bit by so there's a classic bookshelf problem, which is not this bookshelf problem, but a bookcase. I mean, it's similar in that you have books in order. They have certain height and maybe certain width and so forth. Uh, but but the classic bookcase problem is asking you to minimize the height of the highest. Yeah, you have to minimize the height of the highest shelf. And the solution to that one is actually greedy plus binary search. So what ends up happening is you binary search the the answer, quote unquote, which is the height that you can fit, and then you just use greedy on it. So that's kind of, so I mean, and I have, I've done a lot of problems, so I guess I have a lot of these problems that are in my head that I think about when I see similar problems. But sometimes, as you can tell, I get a little like, this is very similar to this problem I've seen. Is there a way I could incorporate that where maybe if you're not thinking along those lines, then you would just jump right into this answer. Having it as an interviewee, I mean, this is a, how did I do? Maybe like 20 minutes ish. Yeah, so I mean, 20 minutes is okay. I think that's at least in terms of difficulty. I think this is probably okay. Maybe a little bit on the harder side. I think my problem as an interviewer, like if I was interviewing and I'm asking this question, my problem is I don't know. I mean, I think my initial problem is I don't know like how to give hints about this problem without giving too much away. You want my ideal problem, you will, is kind of have a thing that like that ramps up its difficulty, if you will, like a little progressively, or maybe this way, depending on how I never know how the camera faces. But meaning if you get stuck at a certain point, I give you a hint. You could go like do a little bit more and so forth and keep going, right? Where like there's certain problems where you give a hint, like suddenly you know how to solve everything because that hint was the entire problem, right? On this one, I think maybe you could do a couple of nudges. I think like the first nudge is, I guess, what you call it, dynamic programming, and I think some of my instincts were kind of right. I mean, I think I probably looking back hand waved over a little bit, which because my mind is racing like 10,000 miles an hour or whatever it is. But because I also mentioned, because one thing I did mention is the shortest path in a graph, and that's essentially what I end up doing. Even though I wasn't able to articulate the cost function, which I kind of alluded to from time to time, and the cost function end up being here, which is the max height. If you look at the cost between two nodes, or if you look at the entire thing as a graph, and each box is a node, or actually not technically, each node or vertex in a graph sense is actually the space between the boxes, if you will. So like, I don't know if I'm saying it right. So definitely ask questions if I'm like just rambling a little bit too much. But so the vertex is the space between the the space between the two boxes, and the edge is just connecting those vertices, and the cost of those edges. So you have an edge between two vertex if the books in between them are shorter than or thinner than the shelf width, and the cost in that case is the height of the maximum book, right? The tallest book within those two vertex, and that's essentially what I implemented, and then it's just shortest path in which we solve with dynamic programming. Looking back in theory, you could solve it a number of ways because it's just shortest path. Yeah, like you could do a breadth of search if you know how to calculate these functions, and just being the cost functions. Looking at the code, I probably could clean it up a little bit. Yeah, I mean that's it. I just need to clean it up a little bit more. Variable names. Some of this not super clear. It's kind of yeah. Cool. I do not have I have a regular degree in computer science or BS. Well, every time I say BS, it sounds kind of weird. But I have a Bachelor of Science in Computer Science. Bachelor, yeah. But yeah.